Okay, next slide. So our topic are broken down into columns, beams, roof design, and weatherproofing. Next slide, please. So here is a brief background for our topic. The structural standards are, its sole purpose is to provide for reliable structures. Specification and standard committees combine the result of research, structural analysis, and engineering judgment in establishing structural standards. The researchers have also compiled the structural standards listing the different ways to build the structure's integrity. And this one is very essential as there is a future structure prevalence of innovative terminals. And not only the Philippine standards have been applied to this research, but also related topics from other countries, which can help us designers to explore a variety of ideas to aid in the proposed terminal design. So next slide, please. So for columns, um, the columns are the parts of the building that transfers the load approaching towards it, along with its weight to the foundation. So this one will talk about the type of column used in bus terminals and the building materials for columns in bus terminals. So next slide. So here is an example of two types of columns according to the Civil Engineering Portal bus terminal design. First is the actually loaded columns. This one, um, the load here is acting towards the centroid of the column and is perpendicular to the section plane. So the next type is the eccentrically loaded and in uniaxial column. The force here is not acting towards the center. So as you can see in the bottom left picture, the force is has an offset from the center. So for uniaxial column, um, loads are not acting on the longitudinal axis of the column section. Then next, for the biaxial column, bottom right, this one, the eccentricity is existing on both axes of the column, unlike the previous. So this one has eccentricity on the x and y axis. So what is previous slide? So what is the importance of this? Because contemporary bus terminal today are architecturally designed like an artwork or like a pavilion, so unusual shaped columns takes a crucial consideration in this study. Next slide. So this one is an example of a bus shelter, the Rotterdam Pink bus shelter in Netherlands. So this one uses stainless steel as columns, and in the bottom right are pictures of the standard details of steel. So in the left side is the standard base plate, and the right applies protection with cement. Next slide. Another example is a bus station in Osijek, Croatia. So there are two types of column used here. First is the reinforced concrete columns for the massive part of the structures and steel columns for the lighter part of the structure. So in the picture, bottom left, this one has a visually light appearance. So it uses steel columns. Next slide. And lastly, these are the universal and standard column dimensions for steel at the top and for reinforced concrete at the bottom. Next reporter.
Good morning, classmates. So for the next topic is about structural beam. A beam is a structural member which spans horizontally between supports and carries loads which act at right angles to the length of the beam. This portion of the report will focus on types of beams in construction, types of beams based on construction materials, and sample buildings. Next slide, please. So for the types of beams, nag-choose lang ko og kanang commonly used in nga akong nakit-an commonly used in bus station or terminal. So the cantilever beam, the overhanging beam, fixed beam, and truss beam. So next slide, please. So cantilever beam is having one end fixed to the rigid support and the other end suspended freely is known as cantilever beam. So it is used for usually for small cantilever beams, the span is restricted to 2 meters to 3 meters wide. So but the span can be increased either by increasing the depth or using a steel or pre-stressed structural unit. So cantilever construction allows overhanging structures without additional supports and bracing. This structural element is widely used in the construction of bridges, towers, and buildings and can add a unique beauty to the structure. So the most prominent issues in the design of reinforced concrete cantilever structures are excessive deflection and balance of moment stability. Next slide, please. So for the excessive deflection, as the span of the cantilever increases, increasing the depth will increase the design load and add to design challenges. So to resist deflection, you may have to increase the compressive strength to the concrete and heavily reinforce the tension and compression zones of the section. So furthermore, forming a web kind design will improve the load distribution on the members, offer higher resistance, and ultimately about shallower sections. So the next is the balance of moment stability. So for cantilever structures to stand, the moment generated at the fixed end must be balanced. So otherwise, equilibrium problem will ensue. So if the cantilever structure has no backspan or kanang dili pareha sa ning sa right side nga picture, then the foundation must be used to provide the balance needed. Otherwise, the structure will topple. So next slide, please. So the second type is the overhanging beam. So it is a simple supporting beam-like structure is commonly used for this sort of beam. In an overhanging beam, however, one end extends beyond the support. So it is the combination of both a cantilever and a beam-supported beam. The overhanging beam is generally used to make balconies and shade with a limited extension in overhanging of 1 meter, but if there is a proper structural report suggesting an extension of more than 1 meter, then it is okay to use. So the uses of overhanging beam is used where it is not practical to provide a support to the beam at one end. So it is also used to support roof extensions. Next slide, please. So the third type is the fixed beam. So this type of beam has fixed ends on both ends. In addition, the fixed beam's rotating movement is controlled. So it cannot be rotated because it is fixed at both ends. So the fixed beam is positioned to withstand high pressure. So the use of fixed beam is mostly used in construction of trusses. So next slide. So the fourth type is the truss beam. So the span of truss beam varies from 10 meter to 100 meter depending type and requirement of the available spaces. So added to that, truss beam provides an economic solution for spans longer than 25 meters. So this type of truss is seen in a frame roof consisting of rafters and ceiling joist. So next. So the next is the types of beam based on construction materials. Next slide. Next slide, please. So first type is the reinforced concrete beam. So it is a plain cement, concrete, and reinforcement bars make up a reinforced concrete beam. It is the most frequent type of beam used in building construction. So this sort of beam can be seen in many residences. So minimum reinforced concrete beam size should not be less than 9 9 inches by 9 inches or 225 millimeter by 225 millimeter with an additional slab thickness of 125 millimeter. So next. For a second type is the steel beam. So steel beams are utilized in warehouse, towers, industrial buildings, and trusses, among other steel construction. Steel I-beams are often employed because they have high second moments of area, so which means they are stiff concerning their cross-sectional area, and steel beams are and can handle a large load without sagging. So advantage of using steel beams are it includes speed, safety, optimal cost, reliability, lightweight, and design adaptability. So next slide. So these are sample buildings or bus station or terminal buildings na akong nakita. So next slide. So the new bus station in Rosenheim, Bavaria, Germany, is they use a cantilever beams. So the bus stations consist of a cantilever roofing structure, so approximately 4.5 meters. So of the total length of 84 meters. So the whole structure is supported by 4 columns. So ang beam na ilang gi-use kay kanang nag-connect um nag-use sila og kanang connections of the primary central beam to the columns and the field joint of the main beam. So ang main beam is kaning nasa tunga kanang large beam dira na nasa picture, and the secondary beams of the column kay kaning nag horizontal. So next slide. So next type of building is the Preston bus station, which they also use a cantilever beams. So it is the central bus station in the city of Preston in Lancashire, England. So in the structure, concrete cantilever beams are exposed on the ceiling, and Preston bus station has suffered some minor but conspicuous repairs and intervention in the past. As admirers of this iconic building, their aim was to leave the original structure untouched wherever feasible. So in one location, the removal of a structure wall from beneath a cantilever beam changed the way the beam behaved and reversing the direction of bending. Next slide. So the Garrido Oriente bus station at Lisbon, Portugal, uses the overhanging beams. So it was built in 1997 in order to serve the Expo 1998. Um, so taking in consideration that this is not only station but a landmark for the city and the first impression for tourists visiting Expo. So concrete structure has been used as a structural system for the interchange building, and for the platform structure is made of steel overhanging beams that forms canopies. So concrete and steel are two materials used in construction. So the building is built in concrete, while all platforms and canopies are built in steel. Main entrance canopy is made of overhanging steel beams arranged in leaf shape. Next slide. Next reporter.
So, hello, sir. I will be reporting on roofs. So, unlike columns and beams, roofs have a very wide scope. So, like the usual roof types alone, like the gabled roofs, they range from 15 to 20 types, and it would have been really hard to fit in 15 minutes. So, for my topic, I chose a select amount of subtopics that I think would line up with the design problem and some of the stuff you mentioned last time, such as storm preparation. So, for this portion of the report, I'll be focusing on general guidelines for roof design based on the Philippine Green Building Code, the design guidelines for storm-resistant roofs, solar roof guidelines, green roofs, just like an intro to solar roofs and green roofs, and notable roof designs in bus stations. So one of the design goals in the design problem was that the bus station should integrate sustainable development design. The design should cover green building technologies, passing growth strategies, solar power, etc. And these are some things that I think can be incorporated into roof design, especially the solar panels, which is why some of the topics focus on structural, green, or sustainable design guidelines for roofs, in addition to the general guidelines that can be applied. Next slide, please. So general guidelines based on the Philippine Green Building Code. So these were the things mentioned about roofs in the Green Building Code. So when it comes to roof colors, light colors can reduce heat transfer from the outside to the inside of the building by having surfaces with a higher SRI. Building metal roof surfaces could either be colored white or have a minimum SRI of 70. So on the upper right, you could have like a chart of like some colors and their SRI. So if you go lower than that, then it might not reduce heat as much. So for the roof insulation, the Green Building Code stated that the insulation can help reduce heat gain and improve thermal comfort, acoustic quality, and reduction in air conditioning load. So buildings should be provided with roof insulation so that the average thermal resistance of the roof is at least R8. So to the right as well, you have like a chart indicating the insulation types such as plastic fiber and their R value. Next slide, please. So storm-resistant roofs, courtesy of architect Ray S. Cabitan, head of the UIP Emergency Architects. So for the form, he suggested that for the hip roofs are generally considered to be the strongest type of roofs because they offer more wind resistance, and in the ideal angles were from 25 to 40 degree angles because they have the best record of wind resistance. For overhangs, large overhangs were discouraged because high wind force builds up underneath them. Roof eaves can be about 18 to 20 inches. If there are large overhangs or canopies, they should be braced by ties held to the structure. So for roofing sheets, long span roofing sheets were recommended. 24 gauge galvanized sheets were required because if the roofing sheets are too thin, nails might tear through the sheet, causing damage. So next slide, please. Roof frame construction. So of course, roof trusses and gables need to be braced, and the design must provide rigid fastening systems for the roof frames, such as metal tie-down straps that tie the roof all the way down to the foundation. Various structural connectors that can reduce uplift need to be provided, and the connectors that can reduce significant roof damage during typhoons. If the rafters are not secure, the ridge can fall apart due to the wind. Collar ties, gussets, and metal straps can help secure the ridges. The connection of the roof framing to the vertical loads, such as the walls or posts, should be accomplished by anchor bolts embedded in concrete cores. The weight of participating at an masonry at an angle of 1/2 horizontal to 1 vertical should be more than the total uplift of the support. In case of large forces, anchoring bars can be taken down to the foundation level with a structural layout that ensures the participation of pillar and cross walls in resisting uplift. So in the next slide, there will be like a couple of images from the presentation that will help visualize the connections. So for bracing, proper bracing should be provided at rafter and eaves levels in a pitch roof, and purlins should be properly anchored at the gable end in order to reduce wind-induced vibration of the roof in cyclonic regions. It is recommended that all members of the truss and bracings be connected at the ends by at least 2 rivets or bolts and welds. Further cross bracing members are welded or connected at the crossings to reduce vibrations. So towards the right, there's like a couple of figures or ideas on how the roof trusses should be connected. So you can visualize how it's supposed to be connected. So next. So for solar roofs, I know that the next group is going to report on this, but I don't think they included the tilt angle or the more like sort of mathematical side to it. So I decided to focus on that. So just a short intro. Solar roofs are roofs that have certain components such as solar panels attached to it that allows it to make electricity from sunlight. So based on a study I read, it will be linked at the reference portion. The Philippines produces about 4.8 kilowatts per square meter of solar cells in a day with peak production of about 6.4 kilowatt hours within a day. So I think to give like an idea of what that means, I think an monitor or computer running for 8 hours takes up about 600 kilowatt hours. I'm not sure, but it's about that in that range. So for the tilt angle, it is important to understand the shading in the roof, particularly in urban areas surrounded by buildings, because even a slight amount of shade can reduce the output. So for our site, I don't think there's a lot of tall buildings that cast a lot of shadow, but then of course, we should conduct a sun analysis to be sure. So solar panels collect maximum solar irradiation per area if tilted in the direction of the equator at an angle equal to the latitude. So there are recommendations from certain studies for the angle. You can look up a fixed sort of standard, but then a study I read recommended this formula below. So 0.812 times the latitude of the site equals the angle from the horizontal facing south. So that's how your solar panels should be angled if you want to compute it. Next slide, please. So for the orientation can be optimized by understanding cloud conditions or by conducting a solar study. In Manila, clouds tend to be greater in the afternoon than in the morning, so tilting it south will receive higher energy in the morning. But if the maximum load is in the afternoon, it will be better to let them face southwest to maximize solar input. So the spacing between the modules need to be 3 times the height of the tilted modules at higher latitudes and at least 2 times the height of lower latitudes. In adapting this rule to the rooftop, there's a limited space, so it is necessary to balance the number of panels that can fit on the roof. And lastly, for aesthetics, it really depends on you how you're going to put it. So, example, for building owners with slope roofs, they just attach the solar panels to the roof in line with the angle of the roof. So, next slide, please. So, introduction for structural guidelines to green roofs. I don't think anyone's covered this yet. So a green roof or a living roof is a layer of vegetation planted over over a waterproofing system. So some of its advantages are that it improves the microclimate. So because it creates a cooling effect, this in turn can reduce the usage of air conditioning. It filters out dust and toxic particles, increases rainwater retention, improves noise protection, reduces energy costs because of what I said earlier, and protects waterproofing due to the fact that it protects from waterproofing from climate extremes. So, hello.
Yes, hello.
Okay, naputol.
Oh,
So for next slide, please. Okay. Ay, wait, ka na, pwede ba? Okay, there. For the types of green roofs, there are 2 types of green roofs. So the extensive green roofs and the intensive green roofs. From what I can see from like some of the designs in the past, I see a lot of students use intensive green roofs, but I don't think like there is a lot of information as to how these are like structurally incorporated into the design, because it's not just putting like a layer of grass, you have to put waterproofing. So for extensive green roofs are like picture just like a flat yard, just like no bushes or whatever, it's just grass. So they require minimal maintenance. Oh, sir.
yes. I missed the time because I was also doing my research here. Try to wrap it up this part in like 1 minute.
Okay, sir. So there are 2 types of roofs. One has like trees, and the other is just like a flat kind of grass. So next slide, please. So these are the structural components. There's a deck layer, the leak detention system, the waterproofing, the insulation. Next, please. The root barrier, the drainage layer, the drainage system, the root permeable filter fabric. Next, please. Next, please. The growing media and the plant cover. Next, please. Next, please. Okay, so this is one of the notable roofs that I found. It's the Rosa Parks Transit System. It incorporates rainwater harvesting within the roofs, and it uses canopies to not only have an aesthetic effect, but also it has like a user, but it preserves the rainwater. So next. This is the Transbay Transport Center, which uses a green roof in the design. Next. And lastly, this is the ZOB port sign bus terminal, which has like sort of a play on light and aesthetics. That's all I'll say.
Sige, anyone else after that? I think.
Good
Yep.
morning. Sorry, sir. What, sir?
There you
Okay,
go.
so weatherproofing. I'm gonna discuss karon sa significance sa weatherproofing. So it's the ability to withstand routine exposure to the elements yet still remain in like new condition. So the importance of it is to reduce hazard gali in any structure na can cause issue para sa passengers and workers. So waterproofing and weatherproofing. So there are two different things kung mo nakag waterproof kay naaman sa water resistant. They are different because waterproof is a long-term na protection sa imong structure, whereas water resistant is the ability to resist the penetration of water to some degree but not entirely. So they are two different things, and we have to opt for the waterproof. So there are many benefits to taking the time and money to waterproof your bus terminal. Here are just a few. So by creating this watertight barrier, you can prevent mildew, staining, rust, odors, breakdown of paints or coatings, insulation, structural damage, and a rich environment for pest invasion. So these are just the things like sa environment sa bus terminal na can infest it kanang sa bus structure. Now, for the weatherproof components, the environment can at any time put a structure under siege. But with clever architecture and advanced materials, houses or structures can defend themselves. Here are how it works on the architectural components of a structure. So, how it works on a foundation. So, alternately, uh, the designers mount the house on piles and cover the gaps with breakaway walls, which detach during a flood. So, for the foundation, nag-focus siya sa flood na predicament. So, for the roof, to further reduce warm, melt-inducing spots, so kung attic imo structure or like higher nga nga component, so ventilate it well and insulate it along the floor rather than the rafters. So how it works on outdoors. So for your trees, keep trees at least 20 feet away to protect your structure or your home from windborne branches. So we have to protect ang mga passenger, mga driver sa bus terminal sa mga trees na area to tumba kung na ay bagyo. So for the lawn or kanang mga bush, something, your lawn is the unsung hero in the fight to help wildfires. So, in case lang nina sa wildfires and stuff. So, prune trees at least 6 feet up so smaller branches will be safe from a low spreading fire and clear away dry, flammable plant materials and mulch. Like that lang. So, dili biya nakasulay ra biya ang Cebu og wildfire. So, we have to um we have to consider that as well. So, how it works on walls. Now, these three are some of the components nga imong magamit for weatherproofing. So, we have an air gap exterior, a steel siding, and a concrete wall. Now, this is the structural drawing of air gap exterior wherein the blue arrows are the wind going in sa crevices sa vertical na panels. So that's the air gap exterior. So if kanang rainfall gani, like ang tubig magpa-down ra siya ba? Like wait, okay, sorry. Forget that. Okay, so ang steel siding it's installed also like this. Um, but it's different sa sa air gap because there is no air nga dapat mosulod diha kay it can affect man ka ng ang inner layer niya nga before sa steel siding. So for the last is the concrete wall. So mao ni siya ang common there is sa Pinas. So if there's typhoon, ang concrete wall jud ang kasagaran nga makita nimo na mag-stand pa ba. So this is the structural drawing of a concrete wall, and ano siya ang concrete wall kung wala pa na na finishing. So sa windows, if ever magput ka windows sa imong terminal, it can be ceramic and unsmashable. It should be unsmashable niya. You can use shutters. You can utilize shutters also, so that na siya resistant to air, to high pressure nga hangin, and kanang temperatures that reach kaning 1,300 degrees Fahrenheit. You can choose from those three. Now, another concept that I would like to introduce is a dome design. We don't usually see it sa sa Cebu, but I think it's worth the shot. So here in the Philippines, we face typhoon or fire ganit. So it's sad that it's like that. So that's why as designers we have to create a sturdy design pero simple ra pud. So most building have lots of stuff that can come off flying off in a storm. Let's say a roof. So ang dome na design, it doesn't have to have a roof, but not necessarily nga di na ka mag-roof. But this is just an idea. So most homeowners seek out familiar shapes, but as survivalists and doomsday preppers looking for secure buildings, more people are moving outside the box into the dome. These houses provide all the security of an underground shelter with the added bonus of sunlight. So when properly constructed, a dome design can work. So sa procedure, to build that perfectly round shape, builders inflate a giant balloon in the shape of of the outside shell. So bali like magkuan ka og form ba sa balloon na takes time, then imo na dayang i-deflate. Then they spray that bubble with 3 inches of urethane foam insulation. When the coating cures, they add 3 inches of concrete reinforced with rebar on top of it, and kind of like constructing a swimming pool in reverse. So mga siya ang dome na section of floor plan. It's a house, so it's not a terminal. I'm sorry, but the concept is what I'm showing here.
Yes, just like 1 minute left.
Okay, sir. Thank you, sir. So for this is the structural form section, and this is how design dome works. So it's proven and tested already. So domes are either continuum structures or formed from lattice frames, dili lang atong and they are generally employed to cover wide spans with relatively dead loads. So ang disadvantage ani is that it could become susceptible to several different modes of instability. So when not constructed right, a dome can fail sa in terms of effectiveness. That's all, sir. Thank you. Next presenter, please.
So in this part, we will discuss some materials that are weatherproofing. So next slide, please. Nakita ka na.
Hello?
Next slide na. Awan.
Nasya sa polyurethane karon sa screen.
So the first type of weatherproofing building materials is polyurethane. So it is the most weatherproofing effective material whenever buildings want to achieve quality waterproofing. So it is regarded as an affordable, durable, and safe way of reducing carbon emissions that lead to global warming and used to make high performance products that are strong but lightweight. Also, it perform well and durable and versatile. So it can also dramatically reduce heat loss in homes and offices in cold weather. And also during summer, they play an important role in keeping buildings cool, which means air conditioning is needed less. So here are some parts that can be used in this kind of material, like cavity walls, roofs, around pipes, boilers, and floors. So next slide, please. So the advantages of polyurethane is buildings last longer and require less maintenance because of the durability of this kind of material, and if it is used in rigid insulation panels, so it is light but strong, moisture resistant, and easy to install, and it also can retain their energy efficient properties for as long as the building exists. And compared to other forms of insulation, so this kind of materials has a much more space efficient, allowing architects and designer to maximize the use of internal spaces. Also, it's particularly versatile and efficient for upgrading old buildings, and not only do it has a good storytell in terms of energy conservation, and they also have relatively small and increasing diminishing carbon footprint. Next slide, please. So the next one is polycarbonate. So polycarbonate is constructed of thermoplastic polymers that is widely used in building and construction products. So according to plastics specialists, polycarbonate materials is durable and malleable, so has exceptional strength, and its properties enable it to withstand significantly high pressure and impact resistance. So transparency is also beneficial for security purposes. So it has very good heat resistance and can be combined with flame retardant materials without significant material degradation. So these materials are engineering plastics in that they are typically used for more capable robust materials such as in impact resistant glass-like surfaces, and it can be used both indoors and outdoors. Next slide, please. So the advantages of polycarbonate is it is easy to bend because it is made of thermoplastic, which means can be easily be formed into different shapes and structures without breaking. So the next one is shock resistant. So compared to glass, this material can withstand more impact. So this is essential when it comes to transportations, handling, and installation phase of architecture. So the next one is it is good insulator. So it has a thermal insulation properties which make it the leading building material for greenhouses, cladding, or roofing projects, and also it can be used in multi-wall polycarbonate sheets and create air pockets. So the next one is it transmits light. So it is amazing at transmitting light, and evidenced by the many skylights, awnings, and sunrooms, and other built using this multiple purpose material. So despite its constant exposure to the sun, it does not yellow over time. So this is because polycarbonate sheeting is treated with UV protection and one or both sides to protect it from potential UV radiation. So the last advantage is it comes in variety of colors. So it is a wide range of colors to match any project you may have. So the color of sheets change vastly under the right lighting conditions, creating beautiful effects, and bright it gives architects, engineers, and designers better control when it comes to bringing their vision to life. So the next slide, please. So the last building material is insulated concrete form. So ICF construction is a method of building walls that are combines concrete with a solid form that is strong, robust, and well insulated. So it provides a wind-resistant construction with a strong continuous load path that keeps the roof, walls, and floor base together during a violent event like pareha sa kanang for especially for bagyo. So during a heavy storm, so these materials also protect a structure and its occupants from projectile debris traveling at speeds of about 100 meters per hour. So these systems are strong and energy efficient, and common application for this method of construction are low-rise buildings with property uses ranging from residential to commercial to industrial. Next slide, please. So the advantages for these materials is strong wall. So it is a primary advantage of strengthening a building wall. So these materials hardens around the ICFs, which then reinforces the wall and reduces its vulnerability to vertical and horizontal forces, depending on whether the frame of the ICF is flat or rigid. So it is disaster resistance and safety, and it also mold rat mildew and insect resistance. So and it has a good advantage of overall comfort. So the next is it is energy efficient and resultant cost saving. So using this insulated concrete form, so it has the potential of reducing the heating and cooling cost of particular building. So it is really good.
Yes, 1 minute.
So it is also good in temperature, stability, sound blocking ability, and it saves materials costs. Next slide, please.
Hello?
Wala pa nakuan sa kita sa kung screen share nga. Next slide.
Okay. So currently on my screen, it's Indian perspective on weatherproofing.
So in this part, so as we all know, India has a tropical climate like here in our country. So Indian perspective on weatherproofing by Sunaina Kumar. So when one lives in North India, one begins to appreciate basic design principles that can make a home comfortable as opposed to the experience of living in sauna through the long insufferable summer, which gives way to a hot and humid interlude before the winter sets in. So architect Lal from Delhi is a proponent of careful design over expensive ideas for climate responsive housing. So he is suspicious of the term green architecture, so which he finds it more of marketing gimmick. So according to him, so
Time up. Any other presenters? After
wala
you.
na sir. Wala na
Okay.
sir.
So, okay, 15 minutes there. Just show me the next of the slides. Okay, next, cooling. Okay, next. cross ventilation, and then weatherproofing. Okay, sige, so I kind of got it. I'll ask for the copy. I'll have the copy man on Canvas. So let's go back to the first section. So you notice you already have 68 slides, too many slides na. So really couldn't fit it within the time. And then the introduction was a bit too general. Like this, you don't need to define a column to us. You don't need to define the beam because we're all, like, especially you guys, kaya third year na mo, come on naman sa beam, kanang column. So go directly to the part that, like, what will help us build the bus terminal. So go next. Next. Like, back, sorry. Back. Yes, just like even for us, I think this is a bit, like, it's good that you notice this actually loaded, eccentrically loaded, but seems like wala nyo gi-apply as a presentation. So if you bring up like a topic like axial loaded, try to add an example. And if you can't find an example, don't just remove it na lang from the presentation. So you're using up like time to discuss something that you're not familiar with. So better just remove it and so discuss something that you already are familiar with. So it's like you're next. Like it's here. You're not even talking about whether this bus shelter is axially loaded or eccentrically loaded. So murag sayang bitaw, sayang ang time, sayang ang slide. So with that, that's also the same problem with the beams. If you go through the beam slides, next, please go to the beam slides. Column dimensions, you got beams, okay, then you're defining the beam again. So you don't need to do that. So go directly to the cantilever beam. What we're trying to find out is how do we build this thing? So we have an image here. It's an exterior image, but like if you go through the slides, go again, just keep going. You have some sections, but almost exclusively exterior images. So it doesn't really tell you how to build the beam. So it's very too basic ang information bitaw. Not so much useful for third year. So if you keep going and you see the same sort of problem with the rest. So the best part of this presentation are really the case studies. And then hopefully in future like examples, you would try to find the section. So I'll share my screen here. Okay. Unfortunately, the presentation wasn't very good. It was a bit too general. I added to our Facebook page video on cantilevers, article on like cantilever design, and a few more reference books that you can download. So the first one, the very easy one is like the Visual Dictionary of Architecture. So when you do presentations on like structure, always have your sections. And this is a free book. You can use it. You can go ahead and like look for it. So look at foundations. How do foundations work? So the foundation is for architecture, like in general, the foundation is only as good as the soil around it. So we don't really have soil data on Cebu. So we can just use like rule of thumbs, like minimum like foundation dimensions, like over here. Usually in the Philippines, I would see the foundation sizes of like maybe 1.5 by 1.5. Foundations are usually square. And they're usually about maybe twice as big as the column size. So if your column size is 300 by 300, your foundation size would be 2 times that. So maybe 600 by 600, something like that. So that's just like a rule of thumb. This is what I was hoping the what they call this, the presentation would include. Like you could have asked your engineering teachers. You can also like I think the book. Reference books. Can you show me your references sa inyong presentations? Like go to the end page. I think they're just websites, if I'm not mistaken. Yeah, websites. Wag yung mga kitag book. So unfortunately, wala kayo. So next time, if you have like a presentation thingy, feel free to ask me, even if I'm not your teacher, because I have a ton of books here that you guys can use. Okay, so another part of the visual dictionary, go to the part on structure. That's, let me just on section S. Oops, sorry. That's R, Q, R, S, sound, stairs, structure. So this is page, let me see here. Page 1251 of the PDF. but it's page 244 on the book. So notice the different types of structures. You're gonna just like, if you just asked me, I could have given you this book and you could just talk about just like the beams, frames, columns, like this stuff, just general. So you can summarize that into like 30 seconds. And since we don't have a lot of data on how big the beam should be, how big the column should be, you can just like focus on the general stuff. So you don't have to attempt to like design it right there and then, or like have some use some data you're not familiar with. So for presentations, always make sure that you're familiar with your data. And if you're trying to find something and then you can't completely explain it, just don't explain it. Just say, nah, we tried to find this thing and we couldn't find it, so we'll just focus on what we have. So for general foundation and structures, I think this is really what's kind of missing in our classes. Like we have some idea of how big the column should be, how big the footing should be, but not really much detail on that. I think that will be introduced in fourth year. As far as I know, I can just give you some rules of thumbs. But for more information, just go through the structure over here. And then my big question here is that the presentation was so focused on different structural types, I didn't give us things that we could use for the bus terminal. So just for everyone, the benefit of everyone, simple post and lintel construction like column and beams will work. Cantilevers, you might want to apply it, but as stated earlier, the weatherproofing section was good. It stated like minimum sort of like roof eave lengths, etc. And then it said there that the roof eave should be like 18 to 20 inches maximum, I think. If you go to the weatherproofing part, I think that was, who was reporting on the weatherproofing part?
Me, sir.
Oh yes, Francis Arteche. Okay, let's go to the part where it said like the roof eaves. Over there, there, overhangs. Whoop. Go back. Okay, overhang. So about 18 to 20 inches long is what they recommend, and that's about just 0.6, I think. just like 20 inches, 2 meters. About 0.5 meters long, which is a bit kanang something new that I didn't know. This was from, asan siya na source, Francis?
It was sort of kanang gikan na siya ni Architecture Kabitan. I just found it like an article online written by him.
Okay, so head of UAP Emergency Architects. So what's this? Did you check when this was like written? It's okay if it's old. I just wanted to know how old it is.
I don't see a date here, sir. I see a time.
Time Raja, date, that's right. Anyway, so I think let me just double check. The UAP Emergency Architects is a new thing, Emergency Architects. Is this the same group with the Typhoon Odette response, or is this a different group? Or is this, you just found it like a UAP Emergency Architects?
I found like marag a presentation, sir, on marag kanang emergency design.
Sige, can you like send that to me and then I'll like go through it. I'll stop presenting as well. Yes. So these are the things that I was like, hopefully we were trying to find. The weatherproofing, I think we can use this. This is new information to me that we can use in our bus terminal. Because like I always say, ang roof eave should be like 1 meter or like 1.2 meters to provide shading from the sun. But if new data has suggested that we should actually reduce that, especially since the bus terminal is basically just a roof structure with columns. So how will we brace our roof so that it won't get damaged by like extreme weather conditions? So,
Friday, May 1, 2015. Ayan.
2015. Okay. So not so bad, 2015. And then another thing that I was hoping that we discuss the structure na wala na discuss is like, how do you treat your ceilings? So this is where I also try to give you guys a bit more insight into this, we go to our Facebook group. I'll also put this into our canvas. The next reference is Manual of a Section. This was published in, I think, the early 2000s. So if you can see, if you want to get creative with your ceilings, you definitely can. Notice that the main structure is the truss, and the ceiling is attached to the truss. So you can actually have different shapes of ceilings. So you can create a more dynamic sort of interior space. But I think for the most part, people will be sticking to what they know, like display, 2 page scrolling. So go through this book so you can have some ideas to what you can do with your structure. And then the strangest one for me is like, how would you apply the dome structure in a bus terminal? Like, would it be feasible, do you think? Like to that student who decided to include the dome structure. For me, I think it's a good exploration, but it doesn't seem practical for a bus terminal. And then for this section of the Sao Paulo Museum of Art, notice that this part here on my right side on the screen, this is basically a cantilever. Notice there are no columns in between the ground floor and the second floor, and supported by these like large beams. And then the foundation is down here. They're also very big. Let me Google you guys an image of the Sao Paulo Museum of Art very quickly. Paulo Museum of Art. So this is where case studies or examples are very important to discuss ideas like structure. So look at this thing. Let me open a new tab. I can't seem to, yeah. Anyway, can everyone see this? Cantilever, or like the ground floor is completely free of columns, and this thing was built. When was this built? Sao Paulo construction date. I'll just look for the wiki. Here we go. I think in the 70s, if I'm not mistaken. This was established 1947. I think the building was constructed, let's see here, 1968. So let's pull up our calculator. 2022 minus 1968. That was over 50 years ago. So definitely you can get very creative with your structure. You just need to explain how it works. So how does the Sao Paulo achieve this? It's with this like external support. It's basically a combination of column and beam that's like supersized, extra large. And you can see with the drawings here in this book that this part here, the front part, it's actually a sort of a hollow combination concrete and steel beam. And I think this would be a solid concrete column. I don't have a section for it. And then the foundations are down here. So let me just try to draw over it. Let's see. Save this image. Maybe I'll just snip it. Snip. So the way this building works, let me just make that. So the foundations are here. This could also be like hollow for all we know. And then the foundation is about like this big on this end. Again, sort of following that, the foundation is about twice the column sort of dimensions. And then I think there's also a basement down here. Yeah, there's also a basement level. So there's a basement level down here, and the column should go down there. But the whole building, this slab is supported by these columns here, and the roof is supported by these columns here. And then the beam sort of holds everything together. So let me change color here, blue. This whole thing, oh, it's black. This whole thing could be classified as a structural frame. And this is also in the visual dictionary. Let me open that up. It's under frame A, B, C, D, E, F. Let me just and then fire safety, fireplace, floor force, frame. Okay. So the cool things about structural frames is that they are sort of strong enough to stand on its own and also carry others' weight. So if you have a structural frame like this simple post and lintel type, you can hang things on top of that and the frame won't move. So you can like increase the size of the frame. You can use the Sao Paulo Museum of Art as sort of like a reference, or other buildings that you might find. Like when we do our schematics, I would expect you guys to have some kind of reference building that will like explain your structure, as well as like your our bubble diagram. So this is what I was hoping the structural group would do. They fell a bit short, but hopefully these other references will help you with your structural designs. So I'll stop presenting here.
If I'm sorry,
Yes, go ahead.
I think I just need to explain what went on because
Okay.
Marag nabaguhan ni sir